Okay, my dear students, let's talk about all these things about the derivatives. Yeah, in the derivatives, we are discuss about tangents line, rates of change. Yeah, and 3.4 derivative functions and the differentiability and techniques of the differentiation, how to differentiate of the given functions, yeah, and derivatives of trigonometric functions, okay. Differential and the linearization of for the function, linearization of the function is this linear functions, yeah, and the chain rule, implicit duplications, and look at here, yeah, look at, and in the derivatives, look at here. First of all, derivatives. Look at here. Derivatives represent the slope of tangent lines and rate of change such as velocity. Means that, do you know that the velocity, yeah? First of all, velocity means that, look at once again. Velocity means, look at here. I would like to zoom this. Okay, great. Look, look at here, this slope, just like that in the circle, yeah. When the another lines and passing through the outline. So this is called the tangentially passing these lines. Okay. So seeing these lines, look at here. Here is the x-axis and y-axis and other curved line is passing things. This is called the tangential lines. And this is also describe the and calculate the area and such as the velocity also and the rate of change also. Okay. Look at here. In this chapter, we will define and the derivative functions using limits. How do we use the limits and what is the limits and what is the derivative and what is the derivative functions? That's all we discuss in these chapters. Okay, look at here. We will develop shortcut techniques for the finding derivatives. Just like that, finding or calculating of the derivatives has various different techniques, but we are also discuss and develop the shortcut techniques, how to calculate derivative quickly and fastly. Okay, look at here. Tangent lines corresponding the local linear approximation of the functions. Okay, implicit differentiation is the techniques and due to the applied related rate problems. Okay, these also we are discussing these chapters. Look at, okay, look at different derivative tangent line and the rate of change. Okay, look at here. Relate differences portions of the slopes of the scant lines and the average rate of change. Know, understand, and applying the limit definition of the derivative of the points. Yeah, this is all things we discuss in these chapters. Look at here. Part A. Second line. Look at here. Second line. This is called the second line. Second line means that, just like that. Do you know that in the circles, in the betweens, if the passes of, sorry, look at, consider this is the circle when the passes of the halfly, so that's we call the diameter, yeah, or diameter also. And when another line passing the not a center, so that's we call the second what, yeah, yeah, this is called the second line also, yeah. Okay, okay, look at here. Okay, all the things here given below. About of this second line, look at what are my second lines here. For now, assume that f is polynomial functions. I hope that you know that the mononomial, binomial, and the polynomial. Okay, f is the polynomial function of the x. F is the polynomial function of the x. Okay, we will relax this assumption in part B. Okay, assume that a is a constant. Okay, what a is the constant. Okay, do you know that constant? Constant means those things which have the fixed value, or those functions which have the fixed values. Okay, look at her. Temporarily fixed and arbitrary real value of x. By arbitrary, we mean that the any real value will do. Later, instead of thinking of the x as a fixed or single value, we will think of the moving or the varying variable can take on the different values. Look at here, what is said that, look, the second line, the second line of the graph of the f from the interval ax. What? Interval of the ax. Look at here. Here is the interval of the ax. Interval means that the between, look at here, a and here is the x. So ax interval is the ax where a is less than x. A is always be less than x. Here is the line that passes through the point a f a. Okay, function of the a, and x is passing through the x f dash, sorry, a function of the x. What is a and what is fa here? A is indicating the x-axis line, and f function of a is indicating the y-axis lines. Okay, and x is here indicating the x-axis line, and fx is the indicating the function of the x is indicating the y-axis line. Just like then, this curves is the, here is the, look at this point, and I'm passing to the second line. This centers here. Here is called the a f a. Okay, and when we, this is called the x f x here. Okay, I hope, are you clear? This is the point names. Okay, and this line is called the second line. Okay, is second is the Latin for to court. Okay, this second is the secare. What? Secare is the court. Second line is come from the secare. Secare means the cutting of the line. Okay, look, the slope of this second line, the slope of this second line, so look at here, rise by run. Do you know that rise by run? Rise by run means those lines which is rising up, and run means those are the which are running, just like that. When we rise the up, but when we run is the horizontal. Yeah, so rise means those curves which are upgoing, and run means those curves which are going to be horizontally. Okay, so look at here, fx minus fa. Okay, and here x minus a. Okay, fx is the function of the x, and fa is the function of the a. Okay, look at it, we call this difference quotient because has the from difference of outputs or by difference of input. Okay, when just like that, when we throw the ball upward, this is the output, and what the get, those balls are comes on the ground, so that is the our input. Okay, let's see tangent line derivatives. Okay, look at tangent line derivatives. Tangent line, obviously, here is the tangent line derivative. The tangent lines and the derivative is that the all things are talking about the tangents. Okay, tangential. Look at here. If you know that, if you know, treat x as a variable, what? Do you know that variable? Variable means value has the different. What? Value has the different, and let x is tends to a. Okay, x is tends to a. Okay, the corresponding second line approach the red tangent line below. Okay, good here. Tangent line, Tangre is Latin from two thoughts. Tangre means two thoughts. That's just simply just like seker is the chord, two chord there. So same here, tangers is the Latin word for the comes from the two chords. Yeah. Or second line to lane to the graph of f must intersect. What must intersect it at least two distinct points. What do you mean? Look at here. Seconds mean that the intersect at least 2 points. Just like that, this point and this point. This is called the second. Okay. Okay. Distinct means that the different point says or tangent line only need intersect the graph one point. This is called the second line. And just like that, this, yeah, this is the one points only thoughts or chords here, so that's we call the tangent line. Okay, I hope clear. Okay, look at here, just touch the graph, there could be other intersection points. Okay, this limiting process makes the tangent line a creature of calculus, not just pre-calculus. Okay, below we let x approach a. Below we get let's approach a. So from the right, what from the right, just like that. Here from the right and sorry from the left here and right here. From the right x tends to a positive and from the left x tends to a negative. Okay, let's see how. Look at here. These all are the tangent line. What? Tangential lines. Okay. And look at here, this is the also tangential line. Look at here, here is the a x3 x2 x1. This all is the interval of the between interval of the a2 ax3 a2 x2 a2 x1. Yeah, here is the interval of the a2 x2 a2 x3. Yeah, this is the intervals. Look at, we define the slope of the, do you know that slope is the mx plus c? Yeah, oh, I hope you know that. Slope of the tangent line to be the two-sided what? Line should be two-sided. Limit of the difference quotients or quotients as x tends to a if that limits exist. Okay. We denote this slope by f dash a, read as the f prime of a. If dash a means f prime of a, prime of a. Okay. Look at here. F prime of a derivatives of f at a, the slope of the tangent line to tangent and the points a, f, a, that is the slope of the exist as a real number, and f is differentiable at a, f dash a is exist. Polynomial functions are differentiable everything on R C section 3.3. The statement of this section apply for the any function. Look at here. The limit definition of the definition of the point A. When the given point A, so that times we are applying this formula f dash a prime A is limit tends to limit x tends to a. Limit means that though anything that with the tilt, yeah, so that likes fx minus f a by x minus a. Here is the given of the fixed points here, so that's be we have to be used that here if x minus a and x minus a. Wow, what is the fx minus a? Just like that. Before the tangential seconds there already we it is already we studied that this like that fx fa x a. Yeah, yeah, it exists. If f is continuous at a, we have the indeterminate limit from 0 by 0. 0 by 0 form is called the indeterminate form. When determinant is formed, that is the very important. If f is continuous at a, not a end there in the a, they are continuously going up, just like this is the going up. So this is called the 0 by 0, and this is the limit form 0 by 0. That's we call the indeterminate form. Okay. Continuity involves limit or function values, while differentiability involves in the limit difference questions. Okay. Let's see. Variable endpoint. Okay. Slope of second line. This is the slope of the second lines. And look at here. This is the example of graph of the second line. A is constant here. Yeah. X is variable. Just like why A is constant here? Because of the A is the fixed points there, but X is not fixed point there. A should be increase or decrease also, but A never be decrease or increase, because of the A is the constant mentioned there. Okay. In the slopes of the second line is the constant and X is the variables, and slope of the second line is function of the x minus function of the a upon by function of the x minus 1s. Okay. X is the here you have to be know that x is the before of the a is the starting points, and here x is the final point or ending points for the cuts there. Okay. Look at here. A second version where x is replaced by a plus h. Look at here. X is replaced by a plus is more commonly used. Why we have to be add the a plus h? Look at here. Slope of the second line, just like that. Here fa and a plus h means that the height somethings. Yeah, look at here, h is the also variables here, just like the not, we can be rise up, so obviously there are going to be heights also increases. Yeah. Okay, so obviously height going to be rise up, so we have to be add there, not subtracts theirs. Yeah. Okay, slope of the second line fa plus h minus fa by h. Okay, this is the variable run. Okay, so look at here, and here a plus h means that here is the x point, not here, because of the h is the here run points. Yeah, the rise is the a plus h f function of the a plus h is the rise, and the here a plus h is the run here. Okay, this is the run formulas. Okay, 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 okay. Okay. Finding derivatives using the limit definition. What? Finding the derivatives using limit definitions. How to use? Look at here. Look at here. Let fx is equals to x cube. Yeah. Function of the x is equals to x cube. This is the, look at here. You have to be know that what is x here and what is 3 here. X is the base. What? X is the base here and 3 is the coefficient. What? X is the base here and 3 is the coefficient here. Okay. F prime 1. What? F prime 1 using version 1 of the limit definition of the derivatives at the points. Let's see. Means that f1, yeah, f1 is equals to limit x tends to 1 fx minus f1s. So you know that this formula is comes from that likes fx minus fa by x minus a. Yeah, this is too similar. Yeah, so here 1 is here, a is equals to 1. Okay, so fx minus f1 by x minus 1. So look at here, Limit extension. We know that fx is equals to the x cube. What? Fx is equals to the x cube. Let's see. So we have to be put or substitute the value x cube minus 1 upon x minus 1. Okay. So let's see what the do. Tip Tip for the brackets here are universally but better safe than sorry. What do you mean it? The bracket here are what unnecessary but better safe than. Not that's an important, but this is safe. That's it. Look at here. Limit x tends to limit x cube minus 1 by x minus 1 here, and when we change this limit from 0 by 0. Is this possible to 0 by 0? How this is the indeterminate form? Look at here. First of all, check the is this determinant for is this indeterminate form? Look at here. 0 cube minus 1 upon 0 minus 1. Basically, we know that minus 1 by minus 1 here. Yeah. So something by something is that 0 cube 0 minus 1. Yeah. No. So look at here. 1 minus cube here, 1 minus 1 here, and here the x is the 1 here, 1 minus 1 here. What? 0 by 0. 0 by 0 is the indeterminate form. Yeah, limit form is the indeterminate form. We will factor the numerator using the difference of two cubes. Okay. Template can the simplify. Synthetic division can also be used. See chapter 2 in the pre-calculus. Okay, let's come see. Look at here. Look at here. Here is the x square plus 1. So when this likes given the function, so we have to be use them. Look at here. Limit x tends to x square plus 1, and when we substitute the value 1, so this get the 3 answer. Look at here. Here is the another methods how to do. Look at here. Look. Example to finding of derivative as point using version 2 of the limit definition. What? Version 2 limit definition revisiting examples. Fx is equals to x cube. Yeah. So in first we are calculating the version first of the limits. Yeah. And in these questions we are calculating the derivatives to version 2 of the limit definition of the derivatives at points. Okay. Here is the point. What the points here? Just like the round points here are the mentions. Okay. So look at it. Here, before the questions, we are using fx minus fa by x minus a. But in these questions, what we are using here? We are using here fa minus fa by, sorry, fa plus h. Got this? F a plus h minus f a by h. These are we using here. So we have to be value put the value because of the given here a is equals to 1. So we have to be use 1 plus h all cube or 1 cube by h because h is not given there. So we will use binomial theorem expand 1 plus h whole cube is equals to a cube plus 3a square b plus 3ab square plus b cube. Yeah, this is the simple formula. So that's here using, and after we get 3h plus 3h square plus h cube, okay, and upon h. So hence when we calculating, so this we get the three answers. F prime is 1 sir. Okay. and finding the equation of the tangent lines. So how to finding the equation of the tangents, like just like the finding the equation of the tangent line to graph y is equals to x cube at the points where x is the ones there, revise of the section 0.14, and lines are the and the pre-calculus notes. Look at here, let fx is equals to x cube as in the example of the 1 and 2. So same similar this likes. Okay, find f1, the y coordinate of the point intersects. So that is the very interesting questions. These are intersecting in the y coordinates, not the x coordinates. These are intersecting the y coordinates. Okay, let's see. So look at here, f1. Why? F1 is equals to 1 cube. Why? Why we are adding the F1? Because of there are the x is equals to 1's given. So we are adding to F1 is equals to 1. And where a 1 cube means x power of the x here. Look at the x curve. 1 is equals to F1 is equals to 1. So the point of the intersection then 1 comma F1. So F1 is the 1 here. So that answer is the 1 comma 1. I have find the f prime 1, the slope m of the desired tangent line. In the part C, we saw twice the f1 is equals to f prime 1 is equals to 3 here. Okay, so this is the simple tangential equation formulas. And